Good morning, everyone. I hope everyone are doing good. And is my voice audible? People are joining. Okay, let's start. So, in this session, we'll see about cryptography. So, basically, cryptography means what? What is cryptography? What all we are going to see in this session is types of cryptography, symmetric key cryptography, asymmetric key cryptography, and various cipher techniques like traditional cipher techniques, whatever they have used. And 5-star structure. This is mainly like it is a base for block ciphers. This diagram will be, this structure is like very important to understand the algorithms. And we'll see about cryptographic algorithms. So, what is cryptography? In Greek, normally crypto means hiding or secret, and graphy means writing. So altogether, cryptography is something writing with like making it secret or hiding it. So that is cryptography. Here, cryptography is the art and science of securing communication and information. So basically, we want to secure whatever we want to convey. It involves techniques for encoding and decoding data to protect it from unauthorized access or tampering. So when we hide any message or anything, others cannot, like basically why we want to hide, others should not access it. So we use cryptography. And types of cryptography. What are the types? Symmetric key cryptography, asymmetric key cryptography, and hash functions. As for now, you know, like symmetric key cryptography uses single key, asymmetric key cryptography uses two keys. And in upcoming slides, we'll see in detail. Symmetric key cryptography. What is symmetric key cryptography? It basically uses single public key or a single private key for both encryption and decryption. If example, for example, person A has to send a message to person B, he will first encrypt his plain text and it will become ciphertext. Now that ciphertext will be sent to person B, and what he will do to view the message? Again he will decrypt the ciphertext and that will become the plain text. So it uses two algorithms, DES and AES. So okay, DES is data encryption standard and AES is advanced encryption standard. In DES, it was like after DES, AES was found because DES found less secure when compared to AES because it has shorter key length, that is 56-bit key length, and when AES, it has multiple key length and multiple rounds. This you will understand when I explain Feistel structure. And next we'll move on to working structure of symmetric key cryptography. Here sender has a plain text. Now she wants to send that plain text to a recipient. Now what she'll do? She'll encrypt a plain text using a private key. And that after encryption it will become ciphertext. After ciphertext, when that ciphertext is sent to the recipient, he will decrypt that ciphertext using a same private key. Hello. Topic लेने के बाद. So guys, I heard that the screen doesn't change, like it didn't change. So whatever I said, this was agenda. Like we'll see about types of cryptography and its techniques and five-step structure. As I said, five-step structure is base for block ciphers to understand and the algorithms. And we'll see about cryptographic algorithms. Sorry for inconvenience. I'll start from first. So what is cryptography? Cryptography in Greek we say crypto means hiding or secret and graphy is writing. So basically what is cryptography? Something writing with like in secret, and if we have to hide that information, we use cryptography. So cryptography is the art and science of securing communication and information. It involves techniques for encoding and decoding data to protect it from unauthorized access. So whenever we want to hide any why we want to hide any message or any data, because others should not access it, so we use cryptography. And types of cryptography includes symmetric key cryptography, asymmetric key cryptography, and hash functions. Symmetric key uses single key for both sender by both sender and receiver for encrypting and decrypting the messages. And for asymmetric key cryptography, they use two different keys for both encryption and decryption. Here they use one private key and one public key. Then hash functions. Hash functions, we all know that it is a unique characters. We can change any data into that hashed text. So this is symmetric key cryptography. Symmetric key cryptography basically uses one private key for both encryption and decryption. Here it uses two algorithms, that is DES and AES. DES is it uses only 56-bit key length, and when compared AES uses three different key length. AES was found after DES because DES has a shorter key length and it was more vulnerable when compared to AES. So AES came into existence. Now this is working of symmetric key cryptography. Here this sender A, she wants to send her text to recipient. Now what she'll do, she'll encrypt her plain text with using a private key, and after encryption it becomes ciphertext. That ciphertext is when sent to recipient, he will first decrypt that ciphertext using a same private key used by the sender, and he will view the message as plain text. Now when you see here, I said the same key is sent from the sender to recipient. So when the sender send her key for decryption, use this key for decryption recipient, then what he'll do, he'll get that key. When you see here, the key is exchanged publicly or privately, when like somehow they have to share their key. So here there are more chance for the eavesdroppers to decrypt the ciphertext. So when this is vulnerable when compared to asymmetric key cryptography. Now asymmetric key cryptography. This asymmetric key cryptography, as I said, it involves pairs of keys, private and public key, for encryption and decryption, ensuring secure data transmission. And it uses two types of algorithms, ECC algorithm and RSA algorithm. These both uses public key as for encryption and decryption. Here when you see here also they have to exchange the public key but not the private key. You will get more understanding in the next slide. See here, this is the example for asymmetric key cryptography. Now Alice want to send a message to Bob, but he is using asymmetric key cryptography. How he will send the message? He is having his plain text. He will encrypt his plain text using the public key of Bob. He will get the public key from Bob and he will encrypt the plain text, and it becomes the ciphertext. Now he will send his ciphertext to Bob. Now Bob has got the ciphertext. Now what he will do to decrypt? He will use his own private key to decrypt the ciphertext, and the plain text will be visible. When you see here also eavesdroppers are there. Now they know that they're sharing their public key, but they can't decrypt it because that message can only be decrypted by Bob's private key. I hope everyone are clear about symmetric and asymmetric. And third one is hash functions. This I think we all know about it because this plain text will go under some hash function along with the security key and it will become the hash text. We'll see hash functions are cryptographic algorithm that transforms data into a unique or fixed size output called hash. This hashed text will be like unique characters and they ensure the integrity and authenticity of data. What are the common hash functions, hash algorithms we use like SHA-2, SHA-256 and MD5? This is hash functions. Now, what are the techniques of symmetric key cryptography? So before moving to the methods, we should know about the traditional cipher methods. There are two types of traditional cipher methods, that is transposition ciphers and substitution ciphers. So substitution cipher is basically putting another letter, like replacing the plain text with some other letter, that is substitution cipher, and transposition cipher is just jumbling the letters, that is transposition. We'll see one by one. Okay, Caesar cipher. This is basically a type of shift cipher. The Caesar cipher is a simple encryption technique. This is a substitution cipher. It was used by Julius Caesar to send secret messages. So see here, basically this Caesar cipher works on the principle of shifting characters. But here the key value is 3. Whenever the key value is 3, that is called Caesar cipher. Other than the 3, anything like if the key value is 2 or 4 or 5, that will be called as shift cipher. We'll see here that alphabets from A to Z are numbered from 0 to 25. So as it is numbered from 0 to 25, we have the plain text called treaty impossible and our key value will be given, that is 3. Now we want to make ciphertext of treaty impossible. How we'll make? See, for example, our first letter is T. T is, where is T? T is in 19th position. Now as we know the key is 3, we have to shift 3 times and we'll get our ciphertext. So from 19, I'll go 1, 2 and 3. What is in 22nd position? That is W. So W is our ciphertext for T. What is the second letter? R. Where is R present? R is in 17th position. So from here I'll shift 3 times. 1, 2 and 3. Whichever is in 20th position, that is U. So U will be our ciphertext for R. Then where is E? E is in 4th position. So I'll shift 3 times. 1, 2 and 3 and it is in 7th position, that is H. H is our ciphertext for E. Likewise, we have to do from T to E, that is treaty impossible. Then now we have got the ciphertext. There is one more way, that is using formula. So first formula is what? C is equal to E of P. What is E of P? So to get the ciphertext, we have to encrypt the plain text. That is our formula, P plus K mod 26. Now what is our P? That is plain text. Where is T present? That is 19. So 19 plus K. 19 plus K, key is 3. So 19 plus 3 is 22. So 22 mod 26 will be 22. So what is 22? It is W. Likewise you can do, and for decryption, same formula with will replace plus is in minus. So to get the plain text, you have to decrypt the ciphertext. What is the formula there? C minus K mod 26. What is our ciphertext here? W. So W is in 22nd position. 22 minus 3 is 19. So 19 mod 26 will be 19. So our ciphertext will be, plain text will be T. So likewise we can do Caesar cipher. This is also a substitution cipher. because as I said, substitution is shifting, substituting the same letter with some other letter. That is why this is called substitution cipher. Next comes Wigner cipher. The key is a repeating sequence of letters. Here when you see Wigner cipher is a polyalphabetic substitution cipher. This encryption happens by plain text letter is shifted by the corresponding key letter. So to encrypt or decrypt the Wigner cipher, we should have Wigner table or Wigner square. So this is our Wigner square. See, when you see here, there are a lot of alphabets. Like our alphabets are arranged in many rows and columns. So this is our Wigner square. Now when you see here, the plain text is thank you and our key is cover. In Caesar cipher, we saw that key was in numerical value. But here in Wigner cipher, the key can be in any alphabet, like any word or any random alphabets you can keep for key. Now you have to place your keys parallel to the plain text. Now when you see here C, O, V, E, R and R ends with K, then what will I do for you? Y? Then again I'll start with C, O, V and it ends with V here. Now our digraph is ready. For T it is C, H it is O. This is the key. We have to make the ciphertext using this key. What we'll do, for example, you see here T, first letter of plain text is T. Where is T here? T, like I'm taking horizontal letters for plain text and vertical text for key. So T is here. What is key for T? That is C. Where is C here? C. So the letter which intersects C and T is V. So V is our ciphertext for plain text T. Again next, what is there? H. For H the key is O. Now where is H here? H is here. And where is O here? O is here. So V again is intersects H and O. So V will be our ciphertext. And for A is here. What is the key for A? A is V. So V intersects V and A. So this is our ciphertext. Likewise, you have to complete till U and it forms a ciphertext. I hope everyone is clear about Caesar cipher and Wigner cipher. Next, we'll move on to Playfair cipher. What is Playfair cipher? It is also the substitution cipher. It was invented by Charles Wheatstone in 1854. Now you can wonder, it was invented by Charles Wheatstone, then how it can be named as Playfair? That is because Lord Playfair is a person who promoted the use of this cipher. Here, first we have to make the 5 into 5 matrix. In 5 into 5 matrix, we will be given a key. Here the key is alphabetic, like it is a word. You have to fill the word, whichever word is given as key, you have to fill that word, and if any letter is repeating, you should put only one time. After that, you should start filling other letters of alphabets. We'll see here with example. See here, totally there are 3 rules. What are the 3 rules is, before moving into this, we'll look after the rules. For example, see, we have to split the plain text into into pairs. For example, Playfair is our example. What we should do? We should split PL is one pair, AY is one pair, and FA is one pair, and IR is one pair. This is called digraph. We call this as digraph in Playfair cipher. And our key here is hello. And when you see here, first what I said, first we should fill the keyword inside the Playfair matrix, like 5 into 5 matrix. So HELLO is the spelling of hello, but only one L is there because we should not repeat a letter. This has only 25 cells. And what was the second rule? Second rule is that we have split, right, that PL, if the plain text 2 letters are residing in the same row, then you should move next for ciphering it. When it is present in the same column, you should move down. and when it is present in different column, different row, you should make a rectangle and you should move to the corner to make a ciphertext. Okay, here we have split PL, AYFA and IR, and we have filled our hello, that is keyword, and after that we have started to fill the all the alphabets A, B, C, D, and E is not there because E is already present, so we should not put E. We should jump to the next letter, that is F. F, G, H. H is already there, and now you see here I and J are present in the same box. Why? Because it is a 5 into 5 matrix. We can put this I and J into same column, same cell. Then K, L is already there, so M, N, O is already there, then P, Q, R, S, T, U, V, W, X, Y, Z. Now our matrix is ready. We know the rules. Then we'll start our encryption process. You see here PL is our digraph. Now P is in this column and L is in this column. So as per our third rule, it is present in the different row and different column. So what should we do? We should make a rectangle here. What is the corner of P? That is M. What is corner to L? That is A. So our ciphertext will be M A. You see here M A is written. Now we'll go for AY. And A and Y is also present in different row, different column. So we are making a rectangle here, and corner of A is O and corner of Y is Z. See, O and Z are next ciphertext. Then FA. F and A is also present in different row, different column. So what is corner of F? F is G, and for A it is O. So GO is our next ciphertext. And for IR, IR is also present in different row, different column. For I, the corner letter is K, and for R, the corner letter is Q. Now we formed a ciphertext. Now we saw only the third rule. So to know more, we'll look after our next example. See here, our keyword is monarchy and the plain text is instruments. See, monarchy, first we'll fill the key letters MONARCHY. We have filled. After that, what should we do? We should fill all other alphabetic letters. Now we have filled, and we have split also, like IN, ST, RUMENT and S. When you see here, Z is added because, as I said, it should be in pairs. This digraph was alone, this S was alone. So we have added Z to pair the S. Okay, now we'll see IN. IN is present in different row, different column. So as usual, we'll move to the corner. So G and A are the ciphertext. Then when you come here, ST. See, according to our rule, S and T are present in the same row. So what should we do? We should move next. What is the next letter of S? That is T. So T is here. And what is the next letter of T? Nothing is there. But what we have to do? We have to wrap up to L. Same column, like a same row. So what is next to T? Next to T is L. That is TL. TL is our ciphertext. Then RU. RU is present in different row, different columns. So we are making a rectangle here. Then corner of R is M and corner of U is Z. So MZ is our next ciphertext. And here comes ME. After ME, see, ME is present in same column. So what should we do? We should move down. What is the next letter of M? Down to M is C and down to E is L. So C and L will be our next cipher digraph. Then NT. NT is present in different row, different column. As usual, corner of N is R and corner of T is Q. And here also S and Z are present in different row, different column. We'll move to the corner, that is corner of S is T and corner of Z is X. Now we have got the ciphertext. Here you can you can have a question like see, for example, hello. Hello is our plain text. When you see here, HE will be one pair and LL can't be one pair. Like similar letters can't be in one pair. So what will I do? After L, I will add Z. So HE, LZ, and next LO will be another pair. So you have to include Z if any same letters are pairing. That's what Playfair cipher says. And we'll move to the next cipher, that is Railfen cipher. So what till now whatever we have seen, that all says about substitution cipher. But this is belongs to transposition cipher. As I said, transposition cipher will jumble the words. It will not add new letter for ciphertext. So see here, it is Railfen cipher. Railfen cipher, we have plain text secret message. What is we are here, and our key can be any number from 2 to number anything we can do, but here I have taken key as 3. When you have secret message, see how many letters are present in secret message. You count 1 2 3 4 5 6 7 8 9 10 11 12 and 13. So we should make 13 columns. This column should be similar to the number of letters in plain text. So we have making 13 columns, and what is our key? It is 3. So we should make 3 rows. So we have made we made this box using 13 columns and 3 rows. Now the box is ready. How should we place the plain text? We should do in diagonal manner. See, SECRETMESSAGE. We have filled the letters in diagonal manner. Okay, now we have filled the plain text. How will we get ciphertext? We have to look in the horizontal manner to get the ciphertext. See, SECERTESGCMA. This is our ciphertext. We should move from left to right, and from first row, then you start with second row, then third row, and here ends the ciphertext. We'll see one more example. Here you see key is 2. Key is 2, so we have made only 2 rows, and this column is similar to the letters in plain text. Here what is our plain text? Defend the east wall. So we have to fill like this: defend the east wall in a diagonal manner. Now we have filled our plain text. What is our ciphertext? As we said, we should move from left. First row you should complete, then you start with the second row. That will be our ciphertext. Guys, I think for certificate they have put the link in the message. You can fill your details to get your to get your certificate. I'll give 2 minutes. You can fill your details in your certificates. Okay, next we'll see about Feistel structure. As I said in the beginning, Feistel structure is the base for block ciphers. If you understand this Feistel structure, it will be easy for you to understand DES and AES structures. So we'll see this in detail. See here, input will be of 64 bit. So as this is the block cipher, this will take input in block. So it is taking input as 64 bits, and it is splitting into left side 32 bits and right side 32 bits. Now 1 minute. Okay. This left side and right side has 32 bits, so totally this consists of 64 bits. Whatever it is taking, like 64-bit plain text, it will give as output 64-bit cipher text. This is what our input and output will give. Input and output will have similar bit size. See, 64 bits is split into two, 32 bits and 32 bits here, and now this right side 32 bits will be sent to a particular function. This is called round function. This function will happen through key K1, and after this function there will be output. That output will be XORed with the left side 32 bits, and next that will be sent to the right side of the second round. And for the left side, the whichever was in right side in round 1, that same 32 bits will be sent to left side 32 bits of second round. So again I am telling, this right side 32 bits will enter this function. This function will happen through key K1, and after this, output of this function is XORed with the left side 32 bits, and this will be sent to the right side 32 bits of second round. And same right side 32 bits of round 1 will be sent to left side 32 bits. And when you notice here, there are 16 rounds, because here this round will happen n number of times. Here n is equal to 16, so it is happening 16 rounds. And here also, for each round, different keys will be given, not the similar keys, like same key will not be taken to the next round. How it is generating? We'll give one original key. That original key, like this round keys will be formed from the original key whatever we have given. So till after 16th round we have got the output, but this is not the original output. This is called pre-output, pre-ciphertext. Now this pre-output has to undergo one more function, that is called swap function. After swap function, this left side will go to right side and this right side will go to left side. Now we have got the ciphertext. This is encryption process, and next one is decryption process. For decryption process, it uses the same keys whatever this encryption process used. See here, we have the ciphertext. This will undergo same function whatever we saw here, but it will take K16. This last round had K16, right? That will be taken here as first round key. First round key, that is, it will go from reverse K16 to K1. First round will be K16 and the last round will be K1. Here also we have got the pre-output. After this pre-output, we have to do one more function, that is what? Swap. So after swap function, this right side will go to left side and this left side will go to right side. So this is what Feistel structure. This function, I said no, this is round function. This should have more confusion and diffusion, like substitution and permutation process it will undergo. But what I mean to say is, like any algorithm, encryption algorithm, which has more confusion and diffusion properties, then that is considered as stronger encryption or decryption process. See, if there are more rounds, this will take more time, and if the key length is more, this is more secure, but it will take more time. And if the key length is small, then it will be considered as vulnerable. So the key and round should be like apt to the security process. And next is cryptographic algorithms. There are many cryptographic algorithms. We'll see about AES, DES and RSA here. So first cryptographic algorithm we are going to see is DES. What is DES? Data Encryption Standard. Data Encryption Standard was introduced in 1977. So this is a block cipher. As we discussed in Feistel structure, this is a block cipher and it will take a block of bits, that is what 64 bits of data, and this key size will be 56 bits. Here also we'll provide only 64 bits of key size, but in each round it will eliminate the 8th bit, so it will become 56 bit keys. So as we saw there, it has 16 rounds. So here what we'll do, 64 bits plain text is taken as input and given to DES, which will produce 64 bits of ciphertext, and it uses same key for encryption and decryption. Okay, what is AES? It is Advanced Encryption Standard. It is a highly trusted encryption algorithm used to secure data by converting it into an unreadable format without the proper key. So, when compared to DES, it uses 3 types of keys, that is 128-bit key, 192-bit key and 256-bit key. Here when we see, it encrypts the data in bytes, not in bits. DES, it encrypts the data in bits, but AES encrypts the data in bytes. So if it is using 128-bit key, it will have 10 rounds of encryption. And if it is using 192-bit key, it will have 12 rounds of encryption. And if it is using 256-bit key, it will have 14 rounds of encryption and decryption. So it was considered secure when compared to DES. So as it uses like AES and DES uses same key for encryption and decryption, we know if it is using same key for encryption and decryption, this belongs to symmetric key cryptography. Now this is RSA, this is asymmetric key cryptography. This was found by Rivest-Shamir-Adleman. These were the 3 people who found this RSA algorithm for encryption and decryption. So till now we have seen that it was like DS and AES, but RSA uses 2 large prime numbers as a secret key for encryption and decryption. When it is 2 large prime numbers, it was found difficult to break the prime numbers when compared to DES. So attackers felt difficult with RSA algorithm and a blowfish algorithm. So this encryption, the public key is used to encrypt data which can only be decrypted with private key. This is what we saw in asymmetric cryptography. He can encrypt the message using public key, but it can only be decrypted using the receiver's private key. Fine. And we have come to the end of this session. Okay. Like till now what all we have seen? What is cryptography and types. In types what all were there? Symmetric key, asymmetric key and hashing. Then we saw about the cryptographic methods, substitution and transposition methods. And in substitution we saw 3 to 4 methods, and in transposition we saw Elfin cipher. And after that we saw Feistel structure, and at last we ended with cryptographic algorithms. I hope everyone are clear about the concepts, whatever we have discussed today. So that is the end of this session, and I hope everyone have registered for their details for the certificates. Thank you guys.